Hello everyone and welcome back. Today's topic is going to be convex mirrors and a mirror equation. And we're going to learn how to calculate where the image is located as well as the magnification that the image is going to have. So first of all, let's talk about convex mirrors. Convex mirrors, we said, are the outer portion of a curved mirror. So if we place an object in front of it, what are we going to see? We're going to see the formation of a virtual image, meaning it is going to be formed on the opposite side of the mirror, and it's always going to be between the focal point and the mirror. We're going to see it to be upright, and always it is going to be smaller than the object itself. As you can see from the picture right next to you, the fighter pilot's helmet that has a convex mirror, and you can see the entire airplane obviously appears smaller, upright, and deep inside the helmet of the person. So, one of the major things that you're going to have to do is going to have to learn how to draw using the same exact rules we discussed, ray diagrams for convex mirrors. So, the first ray is this one right here. So what is it going to be? It's always going to be parallel, of course, to the principal axis system, and it is going to bounce off, and you're going to draw a line extending to the focal point. The second one, which is this one right here, you're going to take it again from the same point. It's going to go towards the focal point. You're going to draw the line extending it, and then you're going to bounce it off parallel to the principal axis. In the third ray, again, you're going to go towards the center and you're going to bounce it off. And all three rays, you're going to draw dotted lines to show that the image simply is going to originate on the opposite side of the mirror. So, with that said, okay, now let's look at the mirror equation. There's a couple of terms that we need to know. The first one is F, which is the focal length. The second one is DO, which is the distance of the object, DI, distance of the image, and M, magnification. And here is the mirror equation. So it's the inverse of the distance of the object plus the inverse of the distance of the image is equal to the inverse of the focal point. And magnification now is given by the height of the image divided by height of the object, and that's going to be equal to the negative distance of the image divided by distance of the object. So if you know the distance of the image and the object, you can find the magnification, and if you know the height of the object, using the same equation, you can actually find the height of the image being created. And I just want to show you from the diagram what is the distance of the image and what's the distance of the object. So the distance of the image is always from the image to the mirror. Distance of the object is always from the object to the mirror. And of course, we all know what the focal length is. Just a quick reminder, focal length for concave mirror is positive. Focal length for convex mirror will always be negative. So let's go ahead and do our first problem. So as you can see over here, we have a convex mirror. So just by reading convex mirror, we know that the focal point is going to be negative. It's used to reflect light from an object that is placed 66 centimeters in front of a mirror. The focal length of the mirror is negative 46. Find the location of the image and the magnification. So let's go to our sketch pad, which is right over here. And let's enlarge it a little bit, okay? And here we go. So what do we have? Okay, so they gave us the focal length, which they gave it to us negative 46 centimeters, and they also gave us the distance really of the object, and they told us that it's going to be 66 centimeters. Now, using the mirror equation, so we said it's the inverse of the distance of the image over the inverse of the distance of the object. That's going to be equal to the inverse of the focal point. Now we can plug in our numbers and solve for it. So in this case, it's going to become 1 distance of the image equals 1 over the focal point minus 1 over the distance of the object. So plugging numbers in, 1 over, now this is going to be negative 46, don't forget, focal point is negative, minus distance of the object, which is going to be 66. So if we put this carefully in our calculator, using, of course, parentheses, closing it, negative parentheses, and putting this fraction in, we're going to get it to be, of course, negative 0.037 centimeters, and that's going to be inversed. And if we inverse this number, we're going to see that the distance of the image is going to be negative 27 centimeters. Now, a couple of things. What does the negative mean over here? It means that the image is going to form on the opposite side of the mirror, just like we expected. Now the problem is asking us to find the magnification. To find the magnification, very, very simply, it's going to be the negative distance of the image divided by distance of the object. So in this case, it's going to be negative the distance of the image, which is going to be negative 27 centimeters, divided by the distance of the object, which is 66. So negative times negative, of course, we all know it's going to be positive. And 27 divided by 66, it is going to be 0.41 in magnification. So just like we expected, because it's 0.41, it is going to be much more diminished than the object. So it's going to be much smaller. And because of the sign positive, that means it's going to be upright. So let's go back and let's just check our findings. And we see that, going back to our PowerPoint presentation, we can see that the distance of the image, just like we said, is going to be negative 27 centimeters. And of course, the magnification, it is going to be negative 41. And just as a quick synopsis, I also made this available to you guys. The most important things is that focal point, it's positive for concave, negative for convex. Distance of the object is positive if it's in front of the mirror. Distance of the object negative if it's behind the mirror. Distance of the image positive if it's in front of the mirror. That's a real image. Distance image negative if it's a virtual image. That means it's going to be behind the mirror. M plus is going to be upright object, and magnification negative is going to be for an inverted object. Thank you so much for joining me. I'll see you in class.